Okay, so let's begin. In the previous class, we were supposed to talk about the switch statement, but due to lack of time, we could not visit that topic. So today, let's start with the switch statement, and we'll move on with with arrays, and I'll be giving a short introduction of arrays. Also, I'll be talking about a project that we will be doing, and we will be implementing all the things that we have studied so far and will be studying in the coming classes. So let's talk about the switch statement first. So let's take a look at the flow diagram for the switch statement. So I'll first have the switch keyword along with, let's say, a variable x. Next, or let's write this as variable for the sake of generality. Let's call this var. Next, we have certain conditions. So we'll have a case here. So if the case is true, then we do something and we have a break statement after the statements inside the case. Now let's say this case was not true, which means it was false. So let's call this case 1. So if case 1 is false, we move on with the next case, that is case 2. Again, we do the same thing. If it is true, we again do something, do some operation. By do something, I mean we do some operation, and then again we come across a break statement. And in a similar way, we proceed until all the cases are met, and finally if all the cases are false, we come at the default case. Now what the default case does is, if all the other cases are false, then this case is executed. So this will simply have, so it doesn't matter whether this is true, the default case is true or false. This default case only executes if all the other cases are false. So there'll just be one path. So let's not write true. There'll just be one path here. So once I arrive at the default case, I'll just, let's say, print a message, and it ends here. If you take a look at the code of the switch statement, so we have switch ch, where ch is a integer type variable. Now inside we have the cases, and the value that I'm going to write after each case is the value that this variable may take. So let's say this is an integer variable, so it may take the values. So let's write it down here. So let's write it in this side. So ch is an integer variable with possible values ranging between 1 and 3, let's say. So there could be three possible values of ch. Those will be our case values. So the first possible value is 1. So if the value of ch is 1, which is signified by case 1, so this is nothing but like an if statement. It checks whether ch is equal to 1. So I'll write that later. So what I do is, let's say inside I do something. So I do something. I'm not specifying any exact operation inside. Just generally you will do something if this case is getting executed. So you come inside, you do something, and then you have a break statement. Now this particular case acts like an if statement. So it checks if ch is equal to 1. So this particular operation is being done by this particular statement, which says case 1. So case 1 generally means if ch is equal to 1. Then I come inside, I do something, and then I break. So this break statement, what it does is that if this case gets successfully executed and I have done something inside, so this break will break off the control outside. So let's say the switch ends here. So let's say the switch case ends here. So break will take my execution directly to the next line after the switch statement. So what does break do? It directly takes the control or the execution to the next line after the switch case, the whole switch case. So breaks basically breaks away from the whole switch case, breaks the control away from the whole switch case. We could have two more options. We could have a case 2, and we could do the same thing. We'll have a break. We could have a possible value of 3, since we are considering the range 1 to 3. So 3 will also be a possible option. We'll do something if it is 3, and we'll break again. Now what happens if the value of ch is neither 1 nor 2 nor 3? So that's where default comes in. So now the default case is something that is executed when none of the cases are true. Okay, so if the value of ch is not equal to 1 or 2 or 3, let's say the value of ch is something other than these three values, then the default statement is executed. The default will again have something, and this it may or may not have a break. So this particular break statement inside the default case is optional. Why? Because we have already come to the end of the switch statement. So default is the case that is always written at the end of the switch statement. That's the last case inside a switch statement, the default case. And since it is the last case, so the break statement here is optional, because after, if I have, if the option, like let's say the situation has become such that we have to execute the default case. So basically it's the last case inside the switch. After that, the control will normally go to the next line after switch. So this break statement, that's why it's optional here. Whereas here, if I do not give the break statement, what will happen is that after executing everything inside this case, the control will fall through to this case and will start executing inside. Again, if this does not have this break statement, the control will automatically fall through to case 3 and it will start executing what's written here. So apart from the default statement, all other cases need a break statement compulsorily. So these breaks are these three break statements are compulsory, whereas the break statement inside a default statement is optional. So I hope that's clear. So now, before we so before we move on to discussing arrays, let's first talk about the project that I was telling you about. So we'll design something called, so the project will be called student. So that will be the name of the project. It will be nothing but a set of classes. We'll design, or rather, let's say a set of classes. We'll design a set of classes to do a few things which you can relate to. For example, let's say you are a student now. So I'll be giving you a program where you'll have a class called student. So this is a class, and you'll design the student class in such a way such that it represents your section at school. So mm, let's say there are 20 students, for example, in your class. So I know there are more than 20 students in your class, but let's say for the sake of simplicity that there are 20 students in your class. So when I give you this tasks to to design the student class, you will work with any 20 students from your class. You can use their names, and you'll have to choose 20 students from the total number of students in your class. So let's say there are 20 students in your class. Each student has a name, a gender, let's say an address as well. So let's say an address, a phone number, and that's it. So let's say each student has 4 fields. So every student has a name, a gender, an address, and a phone number. So each and every student will have a name. Each and every student will have these four, these four values, or these four information about themselves. So you have to design a class student that has these four values, that has a mechanism to store these four values. So basically speaking, you'll have four variables. So this will be a variable. So you will have a variable to store the name, a variable to store the gender, a variable to store the address, and a variable to store the phone number. So you'll design a class student. I'll not tell you how to do it. It will be your homework. I'm just telling you the layout or the way to do it. So you will design a class student. I've talked with you about how to design a class. So you'll write a class student which will have four variables, a variable to store the name, a variable to store the gender, a variable to store the address of the student, and the phone number. These can be imaginary values. It does not necessarily have to be the actual address or the actual phone number. You could use actual names, but that's also optional. I just mean to say that you need to design this class so that it can be used in a real world scenario, keeping that in mind. So we'll write a class which has these four variables, and so let me write down the question. So write a program to design a class called student, and let's not say date, let's say and input the okay. So the question is, you have to design a program or write a program to design a class called student and input the data for 20 students. You would also have to display the data for each student in a formatted fashion. So what do I mean by a formatted fashion? So the output will look something like this. So the output of this program will look something like this. So on the display, when you display everything or the details of every student, so it will say student 1. It will show the name, it will show the gender, it will show the address, and it will show the phone number. So your job is to write a program to design a class called student. You will take input for 20 student, the details of 20 students, and you will display all that details in this format, in this particular format. So you will say for the first student, you'll display student 1. You'll display their name, gender, address, and phone number. Similarly for student 2, student 3, up till 20 students. So that would be your homework. So try and implement this program. Now let's move on to the arrays. So what are arrays? So before we talk about arrays, let's talk a little bit about variables, or what do variables actually behave like. So to understand arrays, first we must answer this question: what is a variable, or what do you understand by a variable? So variable is so consider this. So this is, let's say this is a container. This is an empty container. So this is an empty container, and you could store something inside it. Let's say you could pour water inside the container and store the water. So variable is nothing but similar to an empty container, except that the variable, or rather the container, let's say this container can only store water. Similarly, a particular type of variable can only store a value of that type. So I hope you understand the analogy between these two. So let's say I have an integer variable called x. So x is like, so if you visualize x, so x is like a container. So this is x, and it can only store integers. So anything that you store inside this container must be an integer because it has a data type of int. Now, let's say, uh, let's go back to the student class that I told you to design. So let's consider the student class. So the student class is not particularly full question in and of itself. So I'll be adding one or two things every time, or rather after or before every class or every session that we have. So whatever we are going to learn, we'll be implementing using the student class. So let's say since we are learning about arrays, so how is that applicable to the student class? So let's say you have 20 students. Each student has a certain number of subjects. So we are not concerned about each and every subject or what they are called. We'll be considering the total marks a student gets combining all his subjects. So each student has got a total marks that he or she scored in a test. So let's name the students starting from A. So A is a student, similarly B is a student, and in this way we have A, B, C, D. Let's do this example with 10 students. So that it's a bit shorter. So let's say there are 10 students. So there are 10 students. Each student has got a total marks that he or she has scored in a test. So A, B, C, D, E, F, G, H, I, and J. So A, B, C, D, E, F, G, H, I, and J are the name of the students. Let's say, for example, these are the name of the students, and each and every one of them have got certain marks. Let's say our total marks out of 100. So A has got 70, B has got, let's say, 80, C has got 50, E has got 75, F has got 82, G, let's say, has got 30, H has got 25. Let's say I has scored 95 and J has scored 99. So J is the topper of the class. And H has unfortunately failed. So there are 10 students A, B, C, D, E, F, G, H, I, and J. Each of them has scored a certain marks in a test that was conducted. Now, if I tell you to write a program let's say I tell you to write a program to input the marks of these students, rather 10 students, of these 10 students and uh, display them in ascending order. Let's say I give you this question. I give you the marks of 10 students. The names of the 10 students are A, B, C, D, E, F, G, H, and I and J. This is just for the sake of giving you the example. So it could be any name. But the point is, there are 10 students, and you have to enter the marks of these 10 students and display them in ascending order, which means starting from the lowest marks, you'll have to display this first, then the marks of G will be displayed, then the marks of C will be displayed, and in such a similar way. So ascending order, I hope you know, means from smaller to the larger value. So I give you this particular order. Or let's say you write the program and you take input for these 10 marks and you have to somehow arrange them in ascending order. So before we go on to the arranging part, consider this. If you write a program to input the marks of 10 students, you will obviously need to have 10 variables. So you'll have to have 10 separate variables, int variables or integer variables, to store the marks of each student. Now you'll have to write, you'll have 10 statements. So, or rather, you could have 10 variables, you could define them all in the same line. So int a, b, c, d, e, f, g, h, I, j. So you would have to define 10 separate variables to store the marks of each and every student. And this is just for 10 students that we are talking about. What if there were hundreds or let's say even thousands of students? That's where things get trickier. So let's say you are using a single variable or rather a separate variable for each and every student. This example is just considering 10 students, but in a real life, in the real world, when you are designing a software for a school, the school will not just have 10 students, it will have more than 10 students. It will have hundreds or even thousands of students. So in that case, the problem that will arise is, let's say I have 100 students, you'll have to define 100 separate variables for those 100 students, just for just for storing the marks. Let's say I have other, let's say instead of total marks, I had the marks of each and every subject, and let's say each student had 5 subjects each. So A had 5 subjects, B had 5 subjects, and so on. So there are 10 students, 10 students will have 50 subjects, and you'll have to define 50 variables for 10 students alone. Think about how many variables you will have to define for 100 students, or let's say 1,000 students, each having 5 subjects each. So that becomes much more complicated, right? That's where arrays come in. So arrays are nothing but composite data types. So when we studied about data types, we talked about two types, right? One was the primitive data types, and the other classification of data types was the composite data types. So arrays basically fall under the composite data type. Let's see what are arrays. So as I told you in the previous example, for 10 students, each having a total marks scored in a subject, a total marks scored in a test, you would need to define 10 separate variables. You would have to define 10 separate variables for 10 students. Instead of that, what if um, I had a container that was big enough, excuse me. So what if I had a container that was big enough to store all the 10 values, or rather all the 10 marks scored by the 10 students. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's say I had a container big enough. This is just, let's say, a single container called X. Or let's rather, since we are working with marks, let's call it marks. Let's say instead of having 10 separate variables, we had, or rather 10 separate containers to store 10 different marks. We had one single large container that could store all the marks, all the 10 marks of the 10 students. But the advantage was that I had to just define a single variable to accomplish that. Just imagine how easier it will be if I had to just define one variable that could store, more than one value, but of the same type. So we'll come to that later, but but just imagine I just need to define a single variable. So let's say there's some way to define just a single variable which could store multiple values, uh, instead of a separate variable for each separate value. So that would be pretty interesting. And it will be much more easier to implement while writing the programs. If I let's say if we want to relate it to a real world example, let's consider this example for, let's say I have a house. Okay, you have your own house. Your friend has a different house of his own. Okay, so let's say there are 10 of us. Let's just consider there are 3 of us for simplicity as of now. So each and every person has a separate house built for them to live in. Now, as long as the population increases, let's say instead of 3 now I have more. So as the population increases, so the problem the problem would arise when would have to give each and every person a single separate house in a separate place. So let's say your locality has 20 people, and each of them must be given a separate house to live in. What would happen is, let's say I have this much space in your locality. There are 20 people, each must have a separate house to live in, and the houses must be on different areas. So I'd have to accommodate 20 such houses here in this small space. So I'll have to accommodate 20 similar houses so that 20 people can live in a separate house in this particular amount of area. Now let's say um, 20 more people come to your locality to settle down, but you have the same amount of area left. So you have the same amount of area, your locality is of the same size. Previously it had 20 people, 20 people had 20 separate houses, everything was going fine. Someday 20 more people come and they say that we also want to settle down in your locality. So again you would have to give 20 houses to these new 20 people. But where is the space? Your locality is as big as it was when you had just 20 people, but now it has to accommodate 40 people in total. But you have space only for 20. So how will you accommodate the extra 20? Right. So if you have to give each and every person a separate house in a separate plot of land in your locality, you will someday run out of plots. You'll someday run out of, plots of land or space of land to give. Let's say if other people come, you'll run out of space. Let's say extra people come and want to settle in your area, you'll run out of space. So what's the solution to this? Instead of having a single house or a single home for a single person, you build a flat which has one, two, three, four, let's say five floors. Let's not do this. Let's say it's a single flat with each floor having a single house, a single apartment, and this is in just a single plot of land. Instead of having one house, so instead of having one house in a single plot of land in your locality to accommodate one person, I build a flat which can now accommodate five people in a single plot of land. So if I have more plots of land, I could build more flats like this and I can accommodate more people. So instead of giving each person a separate plot of land, I build a flat and give them an apartment on each floor. This saves space. So arrays work in a similar fashion. So arrays here work in a similar fashion. If say I have 100 values. Okay, let's say I have 100 values. I want to store them in a program. So I'd have to define 100 variables separately for 100 values, right? But with the advent of arrays, I can just define one variable. With the help of arrays, I can define just one variable for all 100 values. How we do that, we'll come to that in a short while, but just know that instead of defining for 100 values, instead of defining 100 variables separately for each of them, we could do it easily using an array and define just a single variable for all 100 values. But there are 2 points to remember, or rather one very important point to remember. All these 100 values must be of the same type, sometimes also called homogeneous in chemistry. So what is homogeneous? Same type. So there's no difference between each value. So let's say one value is 1, the other value would not be 2.5. It would be an integer. So it would be 2 or 5 or 7. So these are all values of the same data type. So this is an integer, this is an integer, this is an integer, this is similarly an integer. So you cannot mix up data types. When I want to use an array to store multiple values in a single, let's call it a single variable name. I want to use a single variable name for all the 100 values. I must make sure that all the values are of the same data type. If they are not of the same data type, I cannot use the same variable to represent all of them. That is the point that you need to remember. So now let's move on to the syntax. So how is an array defined? It's pretty easy. Let's say you want to define an integer array called x, and you have all the values that you want to store in the array. You pretty much know beforehand the values that are going to be stored in the array. Just like the example of the student marks, where I had given you all the marks, 10 marks of 10 students. So you already knew the values of the marks. What you will do is you will define the array in this way. Let's say 1, 2, 3, 4, 5. So I already know what values I must store in the variable. I simply define the array like this. This is the actual syntax of how you define an array when you already know the values that are being stored in the array. There's one more way to define an array. We'll be talking about that later. But for the time being, you can define arrays in this fashion. So you you decide the data type of the array depending on the values that are being stored. So as you can see, all of them are integers. So I define an integer variable x, and I use these particular brackets. These brackets are important, so you have to use these brackets to define an array when you know the values. So I know the values, I just simply store it. What happens? Let's take a look what happens behind the scenes, or how is it stored in memory. So I defined an array x. What happens is, inside memory, inside the computer, 5, uh, let's draw it a bit more uniformly. So 1, 2, 3, 4, and 5. So what happens is, inside memory, 5 consecutive blocks of size int gets reserved for this variable. Now when you specify these values, they are stored in these pockets. So 1, 2, 3, 4, and 5. Just in the order that you have specified, it will be stored in a similar way in memory. So x is a single variable that contains 5 values, 1, 2, 3, 4, and 5. And I can somehow use x to access these values. We'll also talk about that later, but just take a look at how it works. So instead of having x1, x2, x3, x4, and x5, 5 separate variables, I could do the same thing using a single variable when I'm using arrays. So a single variable x now has 5 values instead of x1, x1, x2, x3, x4, and x5. So instead of this calling this x1, x2, x3, x4, and x5, 5 separate variables for 5 different values. Instead of doing this, I defined a single variable x and I assigned all 5 values. I stored all 5 values in this variable x. So x is called an array. X is nothing but an array which is defined as a collection of similar type of values. Remember the word similar type. This is important and you must remember it very carefully. I cannot stress enough how important this is, because if you mix up the data types, your program will not run and you will get an error. So always remember similar type of values. If it is integer, each and every one has to be an integer. If it is a float, each and every one has to be a float. If it is a string, each and every value has to be a string. Remember that very carefully. So this variable x that I have defined now to store all the 5 values acts like an array, which is nothing but a collection of similar type of values. And this is the syntax for defining an array when you know the values beforehand. So Let's go back to the previous question where I asked you to write a program to input. Let's say that let's rephrase the question as write a program to input 10 marks of students, and for let's say for now we just want to display them and display them. So in this case, um, let's say I already know the marks of the 10 students. So let's say the marks of 10 students are 70, 80, 72, 75, 60, 48, 92, 95, 1, 2, 3, 4, 5, 6, 7, 8, and 2 more, 72 and 90. So these are the marks that have been given to me. I need to write a program to input these 10 marks and display them. So as we learned right now, instead of using 10 separate variables to store these 10 different values, what we'll be using is an array. So how will the program look like? Let's take a look. So I'll define a class called marks. Inside marks, I'll define, since all the values are integers, so I'll be defining an integer variable called x, which stands for, well, let's call it score, int score. It stands for the score obtained by each student. And so instead of doing it like this, let's say, so let's do it the old-fashioned way. So let's say instead of class designing, just for the sake of understanding, since I have not told you how to define arrays, um, define first and then initialize them later. So that will be a different part. So the way that I've taught you, the array is defined and initialized in the same line. So for that reason, I am directly writing the um, main method to make it simpler. We'll go to the class designing part later. Let's just take a look. Let's just see how it will look if we write it, the old-fashioned way. So inside class marks, I have a main method, just like we are used to write in old times. And inside the main method, I define a variable x, and I have all these values. This particular line is an array of 10 values. So x is an array which has 10 values which correspond to the 10 marks given to me in the question. Now, rather, so in this case, I have asked you to input 10 marks, but technically we are not inputting marks from the user. We already have the marks. For the sake of, giving an example, so once I'm doing it in this way, once I tell you how to do this, so we are doing two things in this line. Defining an array and initializing it at the same time. This is one way of doing it. So I'm defining the array intx and I'm initializing it with values in the same line. We could do it, we could do the same thing in a different way. Or we could separate this defining part, sorry, we could separate this defining part and the initializing part into two separate lines instead of doing it in the same line. So let's take a look at that. We'll come back to the question. So I could do it in this way, int x equal to 1, 2, 3, 4, and 5. Or, so this is initialization and definition together in the same line. Let's say I want to do it in separate lines. So what I'll do is I'll first define the array. So how do I define an array? Int x is equal to, I use the new keyword, sorry, I use the new keyword, again int, I have the third brackets, and within the third brackets I'll specify the size. Since this array has a size of 5, because it will be storing 5 values, 1, 2, 3, 4, and 5. So there are total 5 values. So I have written 5 within these brackets. So this is my definition. Now, once I've defined it, I'll be using a for loop, and I'll do something inside. Okay, such that these values are initialized to this variable x. And before that, before I tell you how to use the for loop, there's one more thing that you need to know. So when I define this particular line inside memory, I have 5 contiguous or 5 continuous locations. They are rather called contiguous locations. So I have 1, 2, 3, 4, 5. This is what it looks like inside memory. But remember I told you that I could use this variable x or the array variable to access each and every member. But ever wondered how will I do that? Because each value has the same variable name. So let's say if I want to access 1, how will I do that? If I want to access 2, I'll have to again use the same variable name, but the value is different. So in an array, there's something called there's something called an index. So in case of an array, just like if you have let's if you have taken a look at the your roll call attendance register, so they have indexes, or rather if you see the contents of a book, you'll have one, you'll have a chapter 1, you'll have 2, you'll have chapter 2. If you take a look at the contents of a book, it will have something like this. Arrays too have an index by which I can identify each value uniquely. So pay attention, x third brackets or square brackets, if I mention the index number, this will correspond to the value 1. Again the same variable or the array name x, and the next index value, it will correspond to the value stored here 2. Similarly, in a similar fashion, x of 2 will be 3, x of 3 will have the value 4, x of 4 will have the value of 5. Let's take a look at it once more. So x is the name of the x is the name of the variable, the array variable, and the array has a unique index for each and every location. So the first location has an index 0, the second location has an index 1, third location will have an index 2, and in a similar way. Let's say I have this core array which I had defined: 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more, 10. This is the score array. Let's say this is the score array. So according to the previous example, the first pocket or the first space in the array will have an index 0. The second location of the array will have an index 1, and in a similar way up till 1 less than the size of the array. Because it starts from 0, first location is located at the 0th position. So if I have 10 locations, the last location will have 1 less than the total size of the array. So I'm starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are total 10 locations inside this core array. Now I can store 10 different values in these 10 different locations, and I can simply use the index number, let's say score 5, to get the value located at the sixth position. Value located at the sixth position in the array. It's very simple. Just count from the beginning: 1, 2, 3, 4, 5, 6. So the sixth value corresponds to the index 5. So when I say score of 5, the value that I am going to get is the sixth value, or the value at the sixth position of the array. So I'm going to get the sixth value. This is the sixth value inside the array. Similarly, this is the first value inside the array. Similarly, the second value, and so on. Let's say I want the uh, let's say I want the seventh value. Let's say I want the seventh value inside the array. So first, second, third, fourth, fifth, sixth, and seventh. So this is the seventh value. I want to access this seventh value inside the array. So what will be my index number? Let's take a look at the top. The seventh value has an index of 6. So my index value will be 6. This gives me access to the value at the seventh location. Just remember it simply. When I define an array, doesn't matter how big it is, each and every location starting from the first location in the array is numbered serially, starting from 0. So if I have another array, let's say array y, which has a different number of values. So the first index of this y array will always start with 0, 1, 2, 3, and in a serial fashion. If I have more, this will also continue increasing by 1. So the index starts from 0 and increases serially by 1 every time I move on to the next locations. From 0th location, this is the 0th location, or the first location inside the array. 0th index, first location. First index, second location. So remember, in that way, it will always start numbering the array from 0. The computer or the programming language starts numbering the array from 0, and it will continue, serially, increasing by 1 at every, going to every next location, it will increase by 1. The value of the index will increase by 1. Now let's come back to the program. So we defined a class, we defined a class marks. Inside we had the main method, and then we were directly assigning, initializing, defining and initializing in the same line. But instead, right now, what we'll do is we'll define it separately, and then we'll initialize it again separately. So int score is equal to new int. I know there are 10 students, so the size of the array will be 10. Now I've defined an array. Now I'll initialize the array. For here, instead of using default values or values given to you, I'll be using the user input to populate the array or store values inside the array. How will I do that? Let me give a message sopln, enter the marks of 10 students. Now, as I told you, we'll be needing a for loop to populate the array. We generally use a for loop in case of, working with arrays. We almost often will be using a for loop for working with arrays, and manipulating arrays, or storing values inside them, or displaying data from arrays. So in very rare cases we'll be using the other loops, but in general we'll be using the for loop to work with arrays. So as I told you previously, each and every location inside the array will have an index number. So I would need a variable to store that index value. I know the index starts at 0, so the starting value of I is 0. I know the index ends at 9, so it will be less than 10, which means it will end at 9. Once it's 10, it will exit. And I know the index increases by 1 with every location I move forward, so I plus plus. I hope this line, why have I written it in this way, is clear. I is nothing but, I is the index variable. I is called the index variable of the array score, since it points to the index. Okay, since it will hold the value of each and every index, we'll be using the I variable to access the different indexes or different locations in the array. So this is called an index variable because it stores the index value. We know the array starts numbering its first location from 0, so I starts from 0. We know the total size of the array is 10. Since it starts from 0, if you count in your hands, it will go up till 9, so it's less than 10, not less than equal to. Since it will go from 0 to 9, which is 10 values, it is less than 10. And why is it I++? Because every consecutive location that we move on next, the index increases by a value of 1. So after 0, the next location will have an index of 1. The next location will have an index of 2. Again, the next location will have the index value of 3. So it increases by 1. So I++. Now, what we do inside is, so we have the, let's say I've defined the scanner class here, scanner sc. I'm not writing the whole thing. Let's say I've defined the scanner class. Now I'll take inputs. How? So I know the array name, score. Instead of directly using the index value here, I use the index variable here is equal to sc dot next time. So that's how we used to take input for integers using this kind of class. And instead of using the index value directly, since I have to take input for 10 separate values repeatedly, I'm using a variable and a loop to repeat it 10 times. So first time the value of I will be 0. So score 0 will point to the first location. So the first value that the user types will be stored in the first location. Next I'll come back here. I'll increase. I will become 1. It will now point to the second location in the array. So this will be score 1 and it will store the next value, and in a similar way it will store all 10 values. That's how we use a for loop to take input into an array. So the loop runs starting from 0. The loop will run to the number of times the size of the array. So the array has a size of 10, the loop will run 10 times. The array has a size of 100, the loop will run 100 times. The starting value of the loop variable, which is also the index variable of the array, is 0. It will go up till 1 less than the size of the array, and it will increase 1 at every step, increase by 1 at every step. So if we dry run this, so if we dry run this code sample on the side, so when the loop runs for the first time, the value of I is 0. So score 0, I get an input. It is stored in this particular location. The next time the value of I is 1. So for the next input that I get, it gets stored in the location score 1. In a similar way until I go to score 9, which is the 10th location. I finally store the 10th value. Now I becomes 10. So since I is not less than 10, it will exit the loop. So that's how I'm going from starting from the first location. I'm going to each and every location using the iterations of the loop. So in the first iteration, I go to the first location. In the second iteration, I go to the second location, and I, you know, simultaneously save the values that the user is inputting through his keyboard, through his or her keyboard. So that's how you enter values into a loop. Similarly, if you want to display the values, we'll again have to use a for loop. The syntax will be the same. The index variable I will start with 0. It will run up till there are values in the array, and inside I'll have sopln score of I. So let's see, every time I'm using or rather I'm accessing the array, I'm using the index variable instead of using a number directly here. So this particular variable acts as the index variable. So now for each and every loop or for each and every iteration of this particular for loop, it will print a value at the corresponding location. So for the first iteration, it will print the value stored at the 0th location of the score array. For the second iteration, it will display the second value stored at the 1th location of the array, and in a similar way, it will display the 10 different values. So that's the end of the program and how you can, you know, define an array in a separate line. So this is definition. This particular loop is used for initialization. So loop for initialization and loop for display or displaying the values. Okay, so this is the old-fashioned way of how we used to write programs in our previous class. So we used to do everything inside the main function. So that's how we did it as of now. Next, what I'm going to talk about is how to do this using class designing. So that will be the final topic for today's class. I'll just rewrite this program using the class designing process that we have learned in this particular standard. So let's move on to that. Okay, so let's move on to the class designing part. So we'll just rewrite the previous program using class design. Now, this is how we are going to do it. So I have my class here. I'll define the integer variable. So I'll just define it. Let's call it score. And um, you could define the default constructor, or you could leave it up to the compiler. Let's do the whole thing. Let's define the constructor. So this is my constructor. Inside, I'll use the same syntax that I used just now in the previous program. This syntax will more or less remain the same, only this particular value will change according to the size of the array. That's how we initialize the whole array to default values, which is nothing but 0 in case of int. So my constructor is a bit, it's not as simple as it was before, where I just used to, initialize the variable to a default value. Now I have a loop inside the constructor, which initializes the array, each and every location in the array to 0. So that's my constructor. Now I'll write two methods. So one method will feed the array or take input for values from the user and store it in the array, and the other method will display the values. So let's write down the first method, which will take input for the values of the array. So let's say it's a non-returnable method. So void, let's call it feed array. Since I'm feeding values inside the array, let's call it feed array. It does not take any arguments inside. I'll display a message to the user, the same message that I was displaying in the main function. So I'll be doing that here. Enter the marks of 10 students. Now again, just like we did in the constructor, I'll have a for loop to feed the array. Oh, and one more thing that I forgot. So before doing this, since we are um, taking inputs, so since we are working with inputs in this particular program, we'll be needing the scanner class, right? So we have to import the scanner class, import java.util.scanner. Once we have imported the scanner class, we'll be just doing it like we used to. So here I'll define the scanner class since I'm taking input in this particular function. Now I'll display the message to the user and ask him or her to enter the marks of 10 students. Now finally I'll have a for loop which will control the index values and help feed the array, feed the values into the array, just like we defined the for loop in the constructor and the previous program. So I already have defined the variable at the beginning of my class, score. The index variable I is equal to sc dot next int, just like we did in the previous example. Now that's the end of my feed array function or feed array method. This method typically feeds data input by the user into the array. Now we'll have another method called void display. Let's design this method as well. This method has a non-returnable type as well, so it will not have any arguments. Sorry, not arguments, they are called parameters. So it will not have any parameters, and it will simply have a for loop. I'm doing no input operations here, so no scanner class. I'll just display the array, or rather the data inside the array. For same, again the same syntax to access the values inside the array. Same format. Instead of taking inputs, as in this line, we'll be displaying outputs. So let's put this outside, otherwise it will print on each and every line. So let's just put here, let's put a informative message, marks of the students are as follows. Now we'll use the for loop in a similar fashion. So we'll just display SOPLN student. I'm just formatting the output a little bit. So student, a space, I'm doing this to number the students. So student space, now the number of the student, if it is the first student or the second student, that will be done by this particular part. I'll have a colon and I'll display the value inside the array, or the value inside that particular location inside the array. This will typically print, so since I starts from 0, I have done I plus 1. So the first iteration will print student 1 colon and then the marks of student 1. So that's what it is doing. And then the for loop here, it will do its own job and the display method ends here. Similarly, my class ends here. Or what I could do is, I could define the main method in the same class, or I could use a separate class for the main method. So this is my class. So I defined an integer array score to store the number of 10 students, marks of 10 students. I have a default constructor that initializes each array location or array uh, value to 0. I have the feed array function or the feed array method. So I have the feed array method which feeds values into the array taken from the user input. And finally, I have the display method that displays the data inside the array. Now, let's write the main function. So I'm moving on to the side because there is no more space down. Or I could also adjust it in this particular area. So let's write it here. This is the main function that I'm writing. So public static void main. This is all the same, just like we are used to writing the main function. So inside the main function, instead of doing, so everything has been done inside the class. What we'll do is we'll simply create objects of the class like we used to in class designing. So marks, mm, so since score contains the marks of 10 different students, let's say the 10 different students belong to a class. So let's call the object CLS, because I cannot use the name class because it is a reserved keyword of Java. So CLS. So this is the class name marks. CLS is the object name, is equal to new marks. This marks is the default constructor, and now I have a score variable inside this belonging to this object CLS. It stands for okay. So for avoiding any confusion, let's call this standard. STD. So marks standards is the object name It has a variable or an array variable called score, which has 10, which has a size of 10. It can store 10 different values. And let's call the functions, respective functions to first feed the array. So std dot feed array, non-returnable function, so doesn't return anything. Also the display function to display the data that has input. That's all inside main. So I've defined an object of class marks, which is called standard, the name of the object. I've used the object name and called the methods. First method feed array and the second method display, and that does my job. Now I'll end the class. So that's my whole program. So take a look at the total program. So let's take a look at the whole program one last time. So I have a class marks. I've defined an integer array score that stores 10 marks of 10 different students. I have a default constructor which initializes each and every location in the array to 0. I have a feed array function which feeds the sorry which feeds the marks of the students that the user enters from the keyboard in this line using the for loop. I have a display method that displays the value of the array, all the values, all the 10 values inside the array. So it displays it in this way. And finally, I have the main function where I create an object of the class and use the object to call the functions. I could also do this. I could define this as static. Sorry, I could define this not as static. I could define this as private. That would limit the access to this variable, this array. So this, as I told you previously, how private works, it will work here in a similar fashion. Since I'm not, directly using the array inside the main method, I could declare it as private, and it can be accessed anywhere inside this class. So it doesn't really matter. You could even access it inside the main method because I'm writing the main method in the same class. So let's just keep it simple. So that's how you write the program using class design, the same program that we wrote previously, just before. So the student program or the student project that that I told you to do, so it will slowly turn out to be a project, but for the timing, it will look like, small bits and parts of a program. So your job will be to write a program student and define those four variables. So I'll send you the question. You could also, I'll send you the detailed question later on. So you'll have to design a class student. You'll have to define those four variables. Now, you would have to define the main method inside the main. Also you would have to define the functions to take input for those four variables, as well as display the value of those four variables. Next, inside the main method, you would have to take input for 20 students, or let's say 10 students, for example. Let's say we work with 10 students. So you would have to take input for 10 students. So you would need 10 objects. So I'll leave it to you how you are going to implement it. You can use the concept of arrays with objects as well. So think about it, how you are going to, whether you are going to define 10 separate objects or you would use arrays. If you can use arrays, then it's good. So it will show that you have understood the concept of arrays. So arrays can not only be used with variables, I can also define array of objects. You could try it out on your own, or you could do it with 10 separate objects which stand for 10 separate students. You could name them student 1, student 2, student 3, and so on. Take inputs for them and display the data using this particular format of class design. So I'll send you the question, try and do that, solve that question and send it to me as soon as you can, probably before, preferably before the next class. And that should be all for today. So the next class would be on Thursday, usual time. And I hope you would attempt the program that I am going to give you later on today itself. And I hope that you could, you would be able to do it. At least try and attempt, even if you cannot complete the whole program. Try and attempt to, you know, do as much as you can. Okay, so that's all for now.